The morning of April 28, 1944, over the forests of northern France, Luftwaffe Oberleutnant Franz Stigler brought his Focke-Wulf 190 around for what he believed would be a straightforward interception. Below him, a formation of American B-24 bombers was returning from a raid on Friedrichshafen, trailing smoke and struggling to maintain altitude. Stigler had done this before. He knew the routine. Close to within 200 meters, line up the lead bomber in his Revi gun sight, fire a burst from his 4 20mm cannons and 2 13mm machine guns, then break away before the defensive gunners could draw a bead on him. He never reached firing position. From above and behind, 8 streams of tracer fire converged on his aircraft. The sound was distinctive, a ripping noise like heavy canvas being torn apart at enormous speed. Holes appeared in his left wing, his canopy shattered. Something struck his engine, cowling with enough force to send vibrations through the control stick. Stigler threw his Focke-Wulf into a violent bank, diving away from the attack, his heart hammering against his ribs. As he pulled out at lower altitude, struggling to assess the damage to his aircraft, he caught a glimpse of his attacker climbing away. It was massive, bigger than any fighter he had encountered, with a distinctive profile that he would later describe in his after-action report as resembling a milk jug with wings. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What Stigler had just experienced was his first encounter with the Republic P-47 Thunderbolt, and specifically with the weapon system that made the Thunderbolt unlike any fighter aircraft then flying. 8 Browning M2 50 caliber machine guns, 4 in each wing, each capable of firing between 750 and 850 rounds per minute, depending on altitude and temperature. When all 8 guns fired simultaneously, the combined rate of fire approached 6,400 rounds per minute, though the practical sustained rate was lower due to heating and ammunition feed considerations. What mattered to pilots like Stigler was not the technical specification but the simple, terrifying reality. More bullets than any aircraft had ever carried into combat were coming at him faster than he could process. The Germans had encountered American fighters before. The P-38 Lightning, with its distinctive twin-boom design, carried 1 20mm cannon and 4 50 caliber machine guns. The P-51 Mustang, which was just beginning to appear over German skies in early 1944, carried 6 50 caliber machine guns. Both were formidable aircraft. But the P-47 represented something different, something that German fighter pilots and ground forces would come to fear with an intensity that transcended tactical concern and became almost visceral. It was not just a fighter, it was a weapons platform that could pour more firepower into a target in 10 seconds than most aircraft could deliver in an entire combat sortie. This is the story of how the Thunderbolt's armament, designed by engineers at Republic Aviation in Farmingdale, New York, and refined through countless hours of testing and combat evaluation, changed the nature of air combat over Europe. It is the story of German pilots who discovered that the assumptions they had made about fighter armament, assumptions built on years of combat experience and careful tactical analysis, were dangerously wrong. And it is the story of how industrial capacity, translated into raw firepower, could overwhelm even the most skilled and experienced fighter force the world had ever seen. To understand why the Thunderbolt's armament was so devastating, one must first understand what German fighter pilots expected from aerial combat in 1944. The Luftwaffe had not been caught unprepared by the concept of heavy fighter armament. German engineers and tacticians had spent years developing weapon systems optimized for destroying large bombers, which by 1944 had become the Luftwaffe's primary mission over the Reich. The standard German day fighter in early 1944, the Messerschmitt Bf 109 Gustav, typically carried 1 30mm Mk-108 cannon firing through the propeller hub and 2 13mm Mg 131 machine guns mounted above the engine. Some variants carried additional 20mm Mg 151 cannons in underwing gondolas. The Focke-Wulf FW-190 Anton series carried 2 13mm machine guns in the cowling and 4 20mm Mg 151 cannons in the wing roots and outer wing panels. These were not light weapons. The 30mm Mk-108 fired a shell. weighing 330 grams, nearly 3/4 of a pound, at a muzzle velocity of 540 meters per second. A single hit from this weapon could blow the wing off a fighter or tear a devastating hole in a bomber's fuselage. The 20mm MG-151, the standard Luftwaffe cannon by mid-war, fired a shell weighing 92 grams at 785 meters per second. It was an effective weapon, proven in combat since the Battle of Britain. German pilots had learned to close to within 200 to 300 meters of Allied bombers and fire short, precise bursts. The explosive shells would tear through aluminum skin, sever control cables, ignite fuel tanks, and kill crew members. One or two well-aimed bursts could bring down a B-17 or B-24. The tactical doctrine made sense. German fighters were designed to destroy bombers, not to engage in prolonged dogfights with escort fighters. The heavy cannon armament gave them the hitting power to achieve kills quickly. The relatively low ammunition capacity, typically 150 rounds for a 30mm cannon or 250 rounds for a 20mm cannon, was considered acceptable because German pilots were trained to make every shot count. Accuracy mattered more than volume of fire. This philosophy was reinforced by combat experience. During the Battle of Britain in 1940, the Luftwaffe had learned that rifle-caliber machine guns, like the 7.92mm MG-17, lacked the destructive power to reliably bring down modern military aircraft. British fighters could absorb dozens of rifle-caliber hits and return to base. Cannon fire was decisive. A single 20mm shell in the right location could end a fight immediately. By 1944, German fighter pilots had internalized this doctrine. They expected aerial combat to be decided by brief, violent engagements where superior. Positioning and accurate shooting with heavy weapons determined the outcome. They expected American escort fighters to carry similar armament, perhaps 6 heavy machine guns like the Mustang, or a combination of cannon and machine guns like the Lightning. They were not prepared for an aircraft that could put 8 heavy machine guns on target simultaneously, sustaining fire for extended periods with ammunition reserves that seemed inexhaustible by German standards. They were not prepared for the Thunderbolt. The Republic P-47 Thunderbolt was not initially designed as a heavily armed fighter. Its origins lay in a requirement issued by the United States Army Air Corps in January 1940 for a lightweight interceptor fighter. Republic Aviation's chief engineer, Alexander Kartveli, had submitted a design designated the XP-47, which was essentially a scaled-up version of the company's earlier P-43 Lancer. This initial design was relatively conventional, carrying 2 50-caliber machine guns in the nose and 4 in the wings. But by late 1940, as the Battle of Britain raged over England and reports of combat performance filtered back to American engineers, it became clear that lightweight interceptors were not the answer. The Air Corps revised its requirements. The new fighter would need substantial armament, heavy armor protection for the pilot, self-sealing fuel tanks, and most critically, it would need to carry the new Pratt & Whitney R2-800 double Wasp engine, an 18-cylinder radial producing 2,000 horsepower. Kartveli returned to his drafting board and began again. The resulting design was enormous by fighter standards. To accommodate the massive engine and its turbo supercharger system, which was necessary for high-altitude performance, the fuselage had to be broad and deep. The aircraft's size, in turn, meant it could carry more fuel, more ammunition, and more guns than any previous American fighter design. Republic engineers made a critical decision regarding armament. Rather than mixing cannon and machine guns, as some other fighters did, they would standardize on the Browning M2 50-caliber machine gun. This weapon had proven itself reliable and effective. It fired a projectile weighing approximately 43 grams at a muzzle velocity of 890 meters per second. While individual 50-caliber bullets were less destructive than 20mm or 30mm cannon shells, they offered significant advantages in rate of fire, ammunition capacity, and reliability. The standard M2 could fire between 750 and 850 rounds per minute in aircraft installations. This was 2 to 3 times faster than German 20mm cannons, which typically fired at 320 to 480 rounds per minute, and 4 to 5 times faster than 30mm cannons, which fired at approximately 160 to 250 rounds per minute. More importantly, the 50 caliber guns could sustain this rate of fire for extended periods without the overheating and jamming problems that plagued early cannon installations. Kartvelli's team mounted 4 guns in each wing, positioned outboard of the propeller arc. Each gun was fed by an ammunition box containing 425 rounds, giving each weapon approximately 30 seconds of continuous fire at maximum rate. With all 8 guns, the Thunderbolt carried 3,400 rounds of 50 caliber ammunition. Total ammunition weight exceeded 1,000 pounds. The guns were harmonized to converge at approximately 300 meters, creating a cone of fire roughly 3 meters in diameter at that range. Inside this cone, a target would be struck by multiple projectiles simultaneously. Republic test pilots who flew early gunnery trials reported that the recoil from all 8 guns firing together was noticeable, even in an aircraft weighing 7 tons empty and nearly 9 tons when fully loaded. The nose dipped slightly, the airspeed decreased measurably, the sound inside the cockpit, even through the pilot's leather helmet, was described as overwhelming. The first production P-47B model rolled off the assembly line at Republic Aviation's Farmingdale, Long Island facility in March 1942. By the time the aircraft reached operational squadrons in England in late 1942 and early 1943, Republic had already identified numerous improvements needed for combat operations. The P-47C incorporated a longer fuselage to improve stability. The P-47D, which entered production in early 1943, became the definitive variant and the one that German pilots would face throughout 1944 and 1945. Republic Aviation's production capacity grew rapidly as the war progressed. The Farmingdale plant, which had employed fewer than 4,000 workers in 1941, expanded to over 23,000 workers by 1944. The company constructed a second facility in Evansville, Indiana, specifically for Thunderbolt production. This plant, operated by Republic but owned by the government, covered over 1.8 million square feet and employed another 18,000 workers. Between these two facilities, Republic produced 15,663 P-47 Thunderbolts during the war. In peak production months during late 1944, the combined output exceeded 700 aircraft per month. This was more than the entire German fighter production in some months, despite Germany's supposedly advanced manufacturing capabilities and total war economy. Each Thunderbolt represented an enormous industrial investment. The airframe required approximately 15,000 individual parts, not counting the engine, propeller, guns, and instruments. The fuselage was built up from formed aluminum alloy sheets, riveted to a frame of bulkheads and stringers. The wings were constructed as separate assemblies, each containing 4 50 caliber machine guns with their associated ammunition boxes, feed chutes, and charging mechanisms. The electrical system included over 2 miles of wiring. The hydraulic system powered the landing gear, flaps, and gun charging mechanisms. The guns themselves came from multiple manufacturers: Colt, High Standard, Savage Arms, and AC Spark Plug division of General Motors all produced M2 machine guns under license from Browning. Each gun required precision machining of the barrel, receiver, and bolt assembly. The barrels were made from chrome molybdenum steel, rifled with 4 grooves, and fitted with a removable barrel extension at the chamber end. Quality control was rigorous. Each gun was test-fired before installation, and guns that showed excessive wear or tendency to jam were rejected. Ammunition production was equally impressive. The Lake City Army Ammunition Plant in Independence, Missouri, was one of several facilities producing 50 caliber ammunition. At peak capacity, Lake City alone produced over 100 million rounds of 50 caliber ammunition per month. The standard armor-piercing incendiary round, designated MATE, featured a hardened steel penetrator core, an incendiary mixture that would ignite after penetration, and a tracer element that made the projectile visible in flight. These rounds were loaded in 4-to-1 ratio with ball ammunition, giving pilots visual feedback on where their fire was going while ensuring maximum destructive effect. The American industrial system supporting the Thunderbolt program represented a level of productive capacity that Germany could not match. While German factories struggled with Allied bombing, shortage of raw materials, and increasingly desperate labor conditions, American plants operated 3 shifts per day with well-fed, adequately paid workers who had access to modern machine tools and efficient production methods. German intelligence officers analyzing captured American equipment repeatedly noted in their reports the quality of materials, the precision of manufacturing, and the evident abundance of resources that went into every component. By mid-1944, when the 8th Air Force in England and the 15th Air Force in Italy were conducting daily heavy bomber raids into Germany, the Luftwaffe faced a numerical crisis. German fighter production, despite Albert Speer's efforts to increase output, could not replace losses at the rate they were occurring. Experienced pilots were being killed faster than new pilots could be trained, and every day more Thunderbolts arrived in England, each carrying 8 50-caliber machine guns and 3,400 rounds of ammunition. The 56th Fighter Group, known as Zemke's Wolfpack after its commander Colonel Hubert Zemke, was among the first units to take the P-47 into combat over Europe. Operating from Halesworth in Suffolk, England, the 56th flew its first combat mission on April 13, 1943, an uneventful sweep over the Dutch coast. The group's pilots, many of whom had trained on lighter, more maneuverable aircraft, initially disliked the Thunderbolt. It was heavy, lacked the quick acceleration and tight turning radius of aircraft like the Spitfire, and its rate of climb at low altitude was unimpressive. But Zemke understood the Thunderbolt's strengths. Its massive radial engine could take enormous punishment and keep running. Its heavy structure could absorb battle damage that would destroy lighter fighters. Its turbo supercharger gave it excellent performance above 25,000 feet, precisely where the German fighters would have to climb to intercept American bomber formations. And its 850 caliber machine guns gave it firepower that no other fighter could match. The first significant engagement occurred on May 14, 1943, when elements of the 56th intercepted a formation of Focke-Wulf 190 fighters near Antwerp. Major Dave Schilling, leading 8 Thunderbolts, spotted approximately 15 W190s below and dove to attack. The German pilots, experienced combat veterans, expected a conventional fighter engagement. They began their standard defensive maneuvers, breaking formation and turning hard to deny the American pilots a good firing solution. Schilling got behind one Focke-Wulf and opened fire at approximately 300 meters. His combat report, filed after landing at Halesworth, described what happened with clinical precision. He fired a 3-second burst. All 8 guns were functioning. He observed strikes on the enemy aircraft's fuselage and left wing. The wing separated from the fuselage almost immediately. The Focke-Wulf went into a violent spin and crashed. Schilling estimated he had fired approximately 400 rounds total across all 8 guns. Other pilots in the formation reported similar results. Lieutenant Bob Johnson engaged a Tupolev 190 that was attempting to break away. He fired a 2-second burst from approximately 200 meters. The German fighter's canopy shattered. Pieces of the engine cowling flew off. The aircraft rolled inverted and entered a vertical dive. Johnson did not see it crash, but was credited with a probable kill. What struck the American pilots immediately was not just that they were achieving kills, but how quickly targets were destroyed once they came under fire. A 2 or 3 second burst seemed to be sufficient to critically damage or destroy enemy fighters. The volume of fire was so intense that even if most rounds missed, enough struck the target to cause catastrophic damage. German fighters that would have been only lightly damaged by a burst from a 4-gun or 6-gun fighter were being blown apart by concentrated fire from 8 guns. German pilots who survived these early engagements reported back to their squadrons with accounts that seemed almost incredible. They described American fighters that could sustain fire for what seemed like impossibly long periods. They reported seeing their comrades' aircraft literally disintegrate under American fire. They noted that the American pilots seemed less concerned with precise deflection shooting and more willing to simply hold the trigger down and walk their fire onto target through volume alone. Luftwaffe intelligence officers began collecting combat reports and conducting technical evaluations. In June 1943, German forces in Tunisia had captured an intact P-47 that had made a forced landing. Engineers transported the aircraft to Germany for detailed examination. Their report, filed in July 1943, confirmed what pilots had reported. The aircraft carried 8 50 caliber machine guns with total ammunition capacity exceeding 3,000 rounds. The report noted that this represented approximately 4 times the ammunition load of a standard Bf-109G and approximately 3 times the weight of fire per second, despite the smaller caliber of the individual projectiles. The mathematical reality was unavoidable. A Messerschmitt Bf-109G6, the standard German day fighter by mid-1943, carried one 30mm Mk108 cannon with 65 rounds and two 13mm MG131 machine guns with 300 rounds each. Total ammunition weight was approximately 95 kilograms. The cannon could fire for approximately 24 seconds at maximum rate before running dry. The machine guns could fire for approximately 38 seconds. A P-47D carried 3,400 rounds of 50 caliber ammunition, weighing approximately 460 kilograms. Each gun could fire for approximately 30 seconds at sustained combat rate. But because all 8 guns fired simultaneously, the Thunderbolt could sustain maximum fire for 30 seconds, while delivering 8 times the number of projectiles per second that a single gun would deliver. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The German analysis concluded that the P-47's armament represented a fundamentally different approach to air combat. Rather than relying on the destructive power of individual heavy projectiles, the Americans had chosen to overwhelm targets with sheer volume of fire, and critically, they had the industrial capacity to supply this enormous ammunition expenditure to every fighter, every mission, day after day. The true demonstration of the Thunderbolt's firepower came not in air-to-air combat, but in the ground attack role that the aircraft increasingly assumed after D-Day in June 1944. As Allied forces broke out of Normandy and began the advance across France toward Germany, Thunderbolt groups were assigned to provide close air support, interdiction, and armed reconnaissance missions. This meant attacking German ground forces, supply columns, railway targets, and anything else that moved behind German lines. The standard ammunition load for ground attack missions consisted of a mixture of armor-piercing incendiary, armor-piercing, ball, and tracer rounds. Some aircraft also carried high-explosive incendiary rounds for use against unarmored vehicles and personnel. In addition to the 8 50 caliber machine guns, many Thunderbolts carried external ordnance, 500-pound bombs, high-velocity aircraft rockets, or napalm tanks. But pilots quickly learned that the guns alone were often sufficient for most targets. On July 25, 1944, during Operation Cobra, the breakout from Normandy, the 365th Fighter Group flew armed reconnaissance missions over roads south of Saint-Lô. First Lieutenant Bill Kemp, flying a P-47D, spotted a German convoy on a secondary road. His after-action report described the engagement in detail. The convoy consisted of approximately 15 vehicles, a mixture of trucks, half-tracks, and what appeared to be a self-propelled anti-aircraft gun. Kemp rolled in from 4,000 feet, diving at approximately 45 degrees, and opened fire at 800 meters. He held the trigger down for approximately 4 seconds as his aircraft descended through the dive. All 8 guns functioned normally. He observed strikes along the length of the convoy. 3 trucks caught fire immediately. The self-propelled gun appeared to explode, probably from a direct hit on its ammunition. Kemp pulled out of his dive at 1,000 feet and climbed back to altitude. Looking back, he counted at least 5 vehicles burning. 2 more appeared to have run off the road. The entire engagement, from initial dive to pull-out, had lasted less than 15 seconds. German ground forces learned to fear the sound of thunderbolts overhead. The distinctive radial engine noise, different from the inline engines of German fighters or the Allison engines of P-38's, became associated with immediate danger. When Thunderbolts were reported in an area, German convoys stopped moving, troops sought cover, officers postponed movements until nightfall or poor weather grounded Allied aircraft. The psychological impact on German soldiers was profound. A Luftwaffe ground crew member, captured in August 1944 near Falaise, told his interrogators that American fighters had destroyed his unit's fuel trucks, leaving them unable to evacuate their aircraft. He described watching Thunderbolts attack the airfield, making repeated strafing runs. He said the sound of the guns firing was unlike anything he had heard before, a continuous roar that seemed to last forever. He saw aircraft on the ground being torn apart, pieces of aluminum and steel flying in all directions. He counted over 20 aircraft destroyed or damaged beyond repair in a single afternoon. German tank crews reported similar experiences. The top armor on German tanks, designed primarily to resist artillery fragments, was typically 14 to 25 millimeters thick. 50 caliber armor-piercing rounds could not penetrate this thickness reliably, but they could penetrate engine deck armor, vision ports, and other vulnerable areas. More importantly, they could destroy the soft-skinned support vehicles that tanks required: fuel trucks, ammunition carriers, recovery vehicles, and command cars. A tank without fuel and ammunition was simply a stationary pillbox. The most detailed German assessment of the Thunderbolt's ground attack capability came from a report compiled by the 5th Panzer Army in September 1944. The report, based on interviews with survivors of the Falaise pocket, noted that Allied fighter bombers, particularly American Thunderbolts, had made daylight movement nearly impossible. The report specifically mentioned the heavy machine gun armament of American fighters, noting that this allowed them to attack targets of opportunity without expending bombs or rockets. A Thunderbolt could make multiple strafing passes on the same target, each pass delivering hundreds of rounds. By the end of 1944, the statistical record of Thunderbolt operations told a story that no amount of propaganda could obscure. The 8th Air Force in England had flown over 100,000 P-47 sorties. Thunderbolt pilots were credited with destroying 3,752 enemy aircraft in air-to-air combat, making the type the highest-scoring American fighter in the European theatre for air-to-air victories. But these numbers, impressive as they were, represented only part of the Thunderbolt's impact. The ground attack statistics were even more remarkable. 8th Air Force Thunderbolts were credited with destroying or damaging 9,000 railroad cars, 86,000 motor vehicles, 6,800 armored vehicles, and approximately 6,000 locomotives. 9th Air Force Thunderbolts, operating in the tactical role supporting ground forces after D-Day, added thousands more destroyed vehicles, hundreds of bridges cut, and countless supply dumps destroyed. These were not estimates. These were verified counts based on gun camera footage, pilot reports, and post-strike reconnaissance photographs. The ammunition expenditure required to achieve these results was staggering by German standards. American records indicate that in July 1944 alone, Thunderbolt units fired over 17 million rounds of 50 caliber ammunition in combat operations. This was more 50 caliber ammunition than the entire Luftwaffe fired in all calibers during the same month. The disparity in productive capacity, already evident in aircraft numbers, was even more dramatic in ammunition supply. German logistics officers studying American operations could not understand how the Americans sustained such expenditure rates. A typical Thunderbolt mission might involve 8 aircraft, each firing 1,000 to 2,000 rounds. That was 8,000 to 16,000 rounds for a single flight, a single mission, perhaps lasting 2 hours from takeoff to landing. The Americans flew hundreds of such missions per day, and they never seemed to run short of ammunition. The answer lay in American industrial organization. Lake City Army Ammunition Plant alone could produce more 50 caliber ammunition in a week than Germany could produce total fighter ammunition in a month. The United States had sufficient productive capacity to supply not only its own forces but also British, Soviet, and other Allied forces with ammunition. American merchant ships delivered ammunition to forward bases in Europe in quantities measured in thousands of tons. Supply officers treated ammunition as essentially unlimited. Pilots were encouraged to fire freely at any target that presented itself. This abundance created tactical flexibility that German forces could not match. A Luftwaffe pilot with 65 rounds of 30mm ammunition had to carefully select targets and fire only when certain of a hit. An American pilot with 3,400 rounds of 50 caliber ammunition could afford to fire at uncertain targets, to use tracer fire to walk rounds onto target, to make multiple passes until the target was destroyed. The psychological difference was profound. German pilots flew with the knowledge that every round mattered. American pilots flew knowing they had ammunition to spare. Luftwaffe pilots who survived the war consistently mentioned American firepower superiority in their post-war accounts. Adolf Galland, who commanded Luftwaffe fighter forces, wrote in his memoirs that by late 1944, German pilots faced American fighters that were superior in number, in performance, in pilot quality due to better training, and in armament. He specifically mentioned the Thunderbolt's 850 caliber guns as representing a level of firepower that German fighters could not match without sacrificing performance in other areas. German attempts to increase fighter armament during 1944 and 1945 generally resulted in aircraft that were slower, less maneuverable, and more difficult to fly. The Bf-109 G6 with underwing gun pods carried 2 additional 20mm cannons but suffered reduced speed and climb rate. The 4-190A8 carried 4 20mm cannons and 2 13mm machine guns, but was heavier and less agile than Karate. Earlier models. German designers faced impossible trade-offs. American designers, working with a larger, heavier airframe from the start, had built in the capacity for heavy armament without compromising other performance characteristics. The psychological impact on German fighter pilots extended beyond simple fear of American firepower. It represented a fundamental break in the narrative they had been told about German technological superiority and fighting ability. From the beginning of the war, Luftwaffe pilots had been assured that German aircraft were the finest in the world, that German engineering was superior, that German pilots flying German machines would prevail through superior skill and better equipment. The reality they encountered over the Reich in 1944 contradicted everything they had been taught. American fighters outnumbered them. American pilots, many of whom were on their first combat tour, fought with confidence, born from knowing they had better equipment and unlimited support. American aircraft could absorb battle damage that would destroy German fighters and return to base. And American guns, those 850 caliber machine guns on each Thunderbolt, delivered firepower that could shred a German fighter in seconds. Interrogation reports of captured Luftwaffe pilots reveal the depth of this psychological crisis. A Feldwebel pilot, shot down in his Bf-109 near Bremen in October 1944, told his interrogators that he no longer believed Germany could win the war. He had flown over 70 combat missions. He had watched his squadron strength decline from 36 aircraft in January to 12 aircraft in October. Replacements arrived with minimal training, sometimes with fewer than 20 hours in type. They were shot down on their first or second mission. Experienced pilots like himself were simply surviving day to day, knowing that statistically their chances of survival decreased with every mission. He described an encounter with Thunderbolts during his final mission. His Schwarm, a flight of 4 aircraft, had attempted to attack a formation of B-17 bombers. Thunderbolts from high cover dove on them. He saw his Rottenflieger, his wingman, explode under fire from a Thunderbolt that had closed to perhaps 150 meters. The entire aircraft seemed to disintegrate, pieces flying in all directions. He himself took hits in his left wing and engine, his cockpit filled with smoke. He barely managed to bail out before the aircraft became uncontrollable. What struck him most, he told his interrogators, was the casual efficiency of the American attack. The Thunderbolt pilot had not engaged in extended maneuvering. He had simply dove from altitude, lined up the shot, fired a burst, and the German fighter was gone. The American had then pulled up and climbed back to altitude. probably looking for another target. The entire engagement had lasted perhaps 5 seconds. This was not aerial combat, as he had been trained to fight it. This was industrial warfare reduced to its most basic form, overwhelming firepower applied with mechanical precision. Similar accounts appear throughout interrogation records from late 1944 and 1945. German pilots describe watching their formation mates destroyed by American fire, seeing aircraft torn apart or set ablaze by concentrated machine gun fire. They describe the sound of American guns, which pilots who had heard it consistently described as distinctive and terrifying. They describe the futility of trying to engage when outnumbered 5 or 10 to 1, when running low on fuel, when short of ammunition, when flying damaged aircraft because replacement parts were unavailable. The mental toll on surviving Luftwaffe pilots was severe. By early 1945, German fighter units were reporting increasing cases of combat fatigue, psychological breakdown, and reluctance to engage. Some pilots had developed physical symptoms before missions: shaking hands, nausea, inability to concentrate. Flight surgeons prescribed Pervitin, methamphetamine tablets, to keep pilots alert and combat ready. This addressed the symptoms, but not the underlying cause. These men knew they were flying obsolete tactics in outmatched aircraft against an enemy with unlimited resources. American pilots, flying their Thunderbolts, had a very different war experience. While they certainly faced danger, flak remained the primary threat. They flew knowing they had significant advantages. Lieutenant Colonel Francis Gabreski, the top-scoring American ace in Europe who flew Thunderbolts with the 56th Fighter Group, later described the P-47 as a pilot's aircraft. It was rugged, reliable, and forgiving of mistakes. The heavy armament meant that even imperfect shooting could achieve results. A pilot didn't need to be a perfect marksman. He needed to get close enough to bring all 8 guns to bear and fire a sustained burst, and the target would likely be destroyed or at minimum seriously damaged. Gabreski credited the Thunderbolt's durability with saving his life on multiple occasions. On one mission, his aircraft was hit by flak that tore a hole in his wing large enough to climb through. He flew the aircraft back to England and landed safely. On another mission, he took hits from a Bf-109's cannon fire that destroyed his radio and damaged his engine. He nursed the aircraft home at low altitude, barely maintaining flying speed. The Thunderbolt absorbed punishment that would have destroyed lighter fighters. The story of the P-47 Thunderbolt and its 850 caliber machine guns is ultimately a story about industrial warfare and the mathematics of production. The Germans had built a fighter force based on quality and tactical skill. Their pilots were well trained, their tactics were sophisticated, and their aircraft were effective when flown by experienced pilots, under favorable conditions. But by 1944, they were facing an opponent who had built a system based on quantity and material superiority. Republic Aviation produced its last Thunderbolt in November 1945, after the war in Europe had ended, but while fighting continued in the Pacific. Total production reached 15,663 aircraft. This made the Thunderbolt the most produced fighter aircraft in American history until that point. It was not the fastest American fighter. That distinction belonged to the P-51 Mustang at high altitude. It was not the longest ranged. Again, the Mustang with drop tanks had greater range. It was not the most maneuverable. The P-38 Lightning could turn inside a Thunderbolt. But the P-47 was the most heavily armed, the most durable, and perhaps the most feared by German forces. It represented American design philosophy in its purest form. Build an aircraft around the most powerful engine available, give it the heaviest practical armament, make it strong enough to absorb battle damage, and produce it in quantities that ensure numerical superiority. Accept that it might not be the most elegant solution, but ensure that it is effective and that there are enough of them. The 850 caliber machine guns were central to this philosophy. They were reliable, relatively simple to maintain, and supplied by an ammunition production system that could sustain essentially unlimited expenditure rates. They gave American pilots confidence and German pilots dread. They transformed the Thunderbolt from a fighter aircraft into a complete weapons system that could dominate airspace and devastate ground targets. After the war, American military analysts studying the strategic bombing campaign and the air war over Europe identified several factors that contributed to Allied victory. Air superiority was fundamental. Without control of the air, the invasion of France would have been impossible. The advance into Germany would have been far more costly, and the bombing campaign that destroyed German industrial capacity would have failed. The P-47 played a central role in achieving that air superiority. German analyses reached similar conclusions from the opposite perspective. Luftwaffe officers writing in captivity during 1946 and 1947 consistently identified American numerical superiority and firepower advantage as decisive factors in their defeat. They acknowledged that by late 1944, the war in the air was lost. They could not replace aircraft losses, could not train pilots adequately, could not supply sufficient fuel and ammunition, and could not match the combat effectiveness of Allied fighters that had every advantage in numbers, performance, and armament. The lesson was clear and would inform military thinking for decades afterward. In industrial warfare between modern nations, productive capacity matters as much as tactical skill or individual weapon performance. An adequate weapon available in overwhelming numbers, supplied with unlimited ammunition, and crewed by adequately trained personnel, will defeat superior weapons that are scarce, undersupplied, and crewed by exhausted personnel, no matter how skilled. Franz Stigler, the German pilot who encountered a Thunderbolt on that April morning in 1944, survived the war. He later emigrated to Canada and lived there until his death in 2008. In interviews late in his life, he spoke about his war experience with the perspective of someone who had seen both the beginning and the end of German air superiority. He remembered when Luftwaffe pilots had been confident, when their aircraft had been superior, when victory had seemed possible. He also remembered the gradual erosion of that confidence, as American aircraft appeared in greater numbers, as losses mounted, as replacement pilots arrived with inadequate training, as fuel grew scarce, as ammunition supplies dwindled. And he remembered the Thunderbolts, those massive fighters with their 8 machine guns, the aircraft that seemed to embody everything Germany lacked by 1944. Abundance, industrial strength, and the simple, brutal effectiveness of overwhelming firepower. The holes in his Focke-Wulf's wing from that first encounter, the shattered canopy, the damaged engine, these had been repairable. The damage to German confidence, the growing certainty that they were fighting an unwinnable war against an opponent with unlimited resources that could not be repaired. Every Thunderbolt that appeared over Germany carried the same message. America could build these aircraft faster than Germany could shoot them down. America could train pilots faster than Germany could kill them, and America could supply ammunition in quantities that made every German fighter pilot's careful ammunition management look like poverty. The 850 caliber machine guns on each Thunderbolt were not just weapons. They were industrial statistics made lethal, productive capacity given physical form, the mathematics of total war translated into flying steel. And when those guns opened fire, when 8 streams of tracer converged on a German aircraft, they proved with brutal finality that in modern warfare, the factory is as important as the front line. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.